Okay, so this is my code for the zero knowledge proof demonstration in which, so this is basically just a small application of zero knowledge proof where through the use of colored graph, the prover tries to increase the confidence of the verifier without actually telling the verifier the details about the proof statement. In this case, I have taken a proof statement that the prover has two prime numbers and he has to uh, make the verifier believe this too by the use of the three colorable graph. So what the prover actually does is that he converts the proof statement into a three colorable graph and then asks the verifier to choose any two adjacent vertices as many number of times as the verifier wishes. Each time the verifier chooses two adjacent vertices which are of different color, the verifier's confidence or belief about whether the prover is telling the truth or not increases. So, for example, right now I have taken two prime numbers, and these prime numbers are only known by the prover and not to the verifier. So this is the graph corresponding to the two prime numbers the prover has taken, and here the program is asking the verifier to enter two vertex numbers to see their color. And this graph is actually showing the connections between the adjacent vertices. For example, V0 is connected to V2, V3 and V5 and so on. So if we enter 2, 7, which are adjacent vertices, it will show us the color of these two vertices, which is green and red. And since these two vertices are of different color, it indicates or it increases the confidence of the verifier that the graph is a three colorable graph. Because if the graph is not three colorable, then in some step or in some iteration, the two vertices might come with the same color. Again, these two vertices are of different color and thus increasing the confidence of the verifier further. Now, if we again choose the same vertices V7 and V8, it will give us different color. However, they are same vertices, but the color is different. This is because what the program is doing is that for a particular for corresponding P1 and P2 which the prover has given, the arrangement of the graph remains the same, but in each step the three colors of the graph are permuted. This is done so that the verifier does not exactly know the coloring of the graph. Now, another thing to note is that if the verifier keeps on choosing two vertices, adjacent vertices, his confidence keeps on increasing, but it never reaches 100%. This means that the verifier is never 100% sure that the prover has actually given the correct statement or correct proof. It always approaches 100 but never quite becomes 100%. So the confidence keeps on increasing, and also in this particular graph where we have actually taken the two prime numbers correctly, the verifier will never be able to find two adjacent vertices of the same color because it is a true three colorable graph. Now I have changed the two prime numbers which are actually given by the prover and not known to the verifier, so that they are not both prime numbers, and because of that we get a corresponding different graph. Now again, if we choose 0, 5, they are connected and of different colors, which increases the verifier's confidence of the correctness of the proof given by the prover. And if we choose these two edges are not connected, and if we choose 4, 5 vertices, now these two are the same color, which means that the graph is actually not three colorable graph. And now the verifier's confidence, which was previously about 4.76%, now it has gone to 0, because now the verifier has seen that actually there is a pair where the edges and vertices are of the same color, and hence it is not three colorable, and hence the verifier's confidence that the two numbers that the prover has are primes has gone to 0. So in this way, the prover, without actually giving any details about the proof statement, which for here for simplicity we have taken as two prime numbers, without giving any details, the prover is able to make the verifier believe that his proof statement is true by the use of three colorable graph.